This is a 75 series electric actuator with a AF17 positioner board. Going to go through the process of calibrating the board. A few things you need in order to do calibration is you need power on the unit. It goes in 1 and 2. This is a 120 volt unit. Power goes into 1 and 2. And then you also need a signal generator. This is for a 4 to 20 milliamp input signal. Those are going to connect in 10 and 11. Your negative is going to go on 10 and positive on 11. Another thing you'll need is you'll need a meter that reads in ohms, so you can check the potentiometer location. So we're going to start off first with the potentiometer. You look in the back side of the unit here, you can see the potentiometer. You've got two gears. Well, one gear is the gear that is actually on the potentiometer here, and then you've got a gear that's on the shaft. As the shaft turns, it turns the potentiometer gear, and this potentiometer gives an output back to the board, which is connected here on the board, the purple in 1, white, black in 2, and green in 3. So first thing we want to do is we want to check our potentiometer location. In order to check the potentiometer reading, we'll turn our meter on to ohms, and we don't want any power on the unit at this time. Your main power here, you want to have it off or unplugged, and we want to take the leads of the meter, and we want to put one on the white black and one on the purple wire, and it can be negative or positive. We want to make sure the actuator is in the clockwise position. Right now we're in the counterclockwise position. So I'm going to pull the override knob up, rotate the shaft around to where the flag is sitting in the closed position, or the clockwise position. So with the actuator in the clockwise position, we want to take our leads off our multimeter. Before, we want to make sure one of the leads is on the purple wire connection, the other is on the black-white wire connection. Then we want to look at our reading on our meter. Our potentiometer reading should be between 80 and 90 ohms. You can see here it's reading around 62 ohms. So what we want to do with the reading there is we want to reach in, and this main gear here, we want to rotate it around. Get your fingers on it. We'll rotate it around until the potentiometer reads between 80 and 90 ohms. So there we've got it on 85 ohms. So our potentiometer is set in the right location. All right, once we have our potentiometer set on between 80 and 90 ohms, there's 3 trim pots on top of the board. There's a 0, a range, and an AH. What you want to do is we want to, before we put power to the unit, we want to take and we want to turn these pots clockwise around the 0 and the range. We want to turn them all the way around clockwise till they stop. Now the flats on these trim pots should be running between 11 o'clock and 5 o'clock on both of them. The dead band here for the board, it's usually set right. You don't have to make any adjustments to it normally, so we'll leave it alone. All right, now that we've got our trim pots where they need to be, and we've got our potentiometer set, we'll put power to the board, and we want to make sure that we've got a signal going to the board. So we've got 4 milliamp signal, and we'll put power to the board. So we've got 4 milliamps to it, and the actuator is rotating around toward the closed position. And with the trim pot set where they're at, this actuator shouldn't go all the way to the closed position. It's going to stop short of closed. Alright, the actuator stopped. So what we'll do now is we'll take in our zero pot here, we want to turn it a little bit counterclockwise, and the actuator is going to move. Just slowly turn it just a little bit until the actuator gets in the closed position. So we've got that adjusted. Now we'll, with our signal generator, we'll give it 20 milliamps. The actuator is going to start back rotating counterclockwise or to the open position. And it's going to stop quite a bit short of the open position. Now what we want to do is we want to come in, and the same thing with our range. We want to slowly turn it counterclockwise until our indicator gets on the open position. Or if you mount it to the valve, you can look in your valve and tell the position of your ball. Okay, now we're right at the full stroke now. We want to go back now and give it 4 milliamps, and we'll have to make a minor adjustment to it because these two trim pots work together to set the range. Alright, we're back at the range, and you notice it stopped a little bit short. We'll come in, turn our zero trim pot just a hair bit more. Alright, now we're at the zero position. We'll give it 20 milliamps. We'll rotate back to the open position again, or the counterclockwise position. Just make sure that our range is good. And we've stopped right on the open position. And now what we want to do to make sure that that it's functioning the way it should, before I go any further, I'll go back up underneath here. There's two cams that's right in here that work off of this switch and then this other switch over here. These are safety switches. You want to make sure that the cams are set not where they're tripping the switch, but just right before they trip the switch. And I'm going to explain that here in just a second, how that works. So we're in the open position or full counterclockwise at 20 milliamps. We want to give it 12 milliamps now. And this actuator should rotate around until it gets about 50% position, and it's going to stop. So here we are, we're at 50%. The motor stopped, and we're tracking good with our position. Now what we want to do is we want to cut the power off to our signal. When we do that, this actuator is going to start rotating around to a fail position. It's set up for fail close or fail clockwise. So it's going to rotate around until it gets to the point that it's tripped this switch here. And that's what I'm talking about, a safety switch. With these switches tripped, it won't let the actuator rotate around anymore. Now when we give it signal back, we'll turn the signal generator back on. It should start back moving again. It's going to jump right back in to tracking. That's one test that you want to do to make sure that your travel stops it down here next to the switches is set correctly. Right now I've got it on 4 milliamps. You can see it's going to rotate around, and it stopped at the clockwise position, but it has not tripped the switch with the 4 milliamps still on it. I can reach in here, pull, and you can hear the switch click. So we're in good shape on the calibration of this actuator. It's ready to be put in service.